Hi everyone, I'm Kazuhiro Ikkyu and a doctoral course student at the University of Tsukuba. Today's topic is MTL4MHC2, MHC class 2 binding prediction by using multitask learning. Cancer vaccine is one of the promising cancer treatments. Particularly, it is known that cancer vaccine is effective for refractory cancer. Cancer vaccine is designed from cancer-specific antigen, which is called neoantigen. Neoepitope is neoantigen which induces immune response. This immune response was caused by peptide-peptide interaction between neoepitope and immune receptors. So neoepitope is required binding affinity for two immune receptors. They are MHC class 1 and 2. Class 1 relates immune in cellular immunity and an antigen presentation of cancer, whereas class 2 induces humoral immunity. Both functions are essential for cancer vaccine. Generally, neoepitope candidates have been screened by deep learning prediction. Class 1 prediction performance achieved around 89% of AUC-ROC score, but Class 2 prediction performance is insufficient. It is around 70%. There are for several reasons. One of the reasons is that the training data of neoepitope prediction depends on bioassay. There are a lot of different kinds of MHC class 2 receptors. Therefore, it is difficult to collect training data of MHC class 2. In this study, we try to improve the prediction performance of MHC class 2 from limited training data by using multitask learning. Multitask learning is trained from multi-input. Then learning parameters are shared. It is known that parameter sharing reduces the risk of overfitting and improve prediction performance complementary. We designed and tuned multitask model which consists of MHC class 1 and 2 inputs. It is called MTL4MHC2. MTL4MHC2 was designed based on MHC@net, which is existing biolestin-based prediction model. Model inputs consist of antigen peptide sequences and MHC binding site sequences. Input data of MTL4MHCs are MHC class 1 and 2 data. All models were adopted same embedding method. Antigen peptide was embedded 100-dimension vector by monogram token. MHC peptide was embedded 100-dimension vector by trigram token. Label data was composed of bound or non-bound based on binding affinity. These methods were followed MHC@net methods. As a comparison, we also created multi-head attention model. Multi-heads were created from the hidden layer of biolestin by linear transformation and regularization of recurrent kernels. All models were trained by using IDB dataset. IDB is MHC binding affinity database and has been used well in this field. This dataset was used for MHC@net researches. Hyperparameters were tuned by grid search method like this. Optimal parameters are as shown in table. From here, I will talk about prediction performance results. Models are evaluated by two datasets. As I said above, IDB dataset is used in MHC@net. Dataset of nanofiber repository is independent data of another database. We selected this dataset in order to evaluate generalization performance. Firstly, this figure shows the evaluation result of IDB dataset. From left to right, MHC@net model, tuned biolestin model, multi-head attention biolestin model, and MTL4MHC2. Parameter tuning improved biolestin model from comparison between MHC@net and tuned biolestin. MTL4MHC2 was the highest performance in all models. it is shown that prediction performance was improved by multitask running. But MTL4MHC2 still have strong and weak points. Please see the figure of comparison between MHC class 2 subtypes. This figure indicates the comparison of the prediction performance of two MHC class 2 subtypes. There is a difference in prediction performances. This result exhibited that there is still room for improvement. Secondly, this figure indicates the result of another dataset, MHC AtoNet tuned by RSTM and multi-head model showed equivalent performances. This result shows that generalization performance was not improved by parameter tuning. That is to say, parameter tuning of RSTM was specialized in IEDB dataset. On the flip side, the prediction performance of MTL4MHC2 was the highest in all models, same as the result of IEDB dataset. Overall, it is considered that MTL4MHC2 achieved performance improvement by multitask running efficacy. Finally, we compared MTL4MHC2 with existing prediction models. MTL4MHC2 was the highest ACROC score. As a summary, we demonstrated effectiveness multitask running for improving prediction performances from low amount of data. In future, we confirm prediction performances between antigen peptide and pair receptors, and we feel like to utilize MTL4MHC2 for discovery and developing novel cancer vaccine. Thank you for your attention.